Hello everyone, welcome to Online Maths TV. Today we have a challenge on the board. I know preparation is on ground with regards to the Christmas. So to my Christian brothers who are preparing for the Xmas, we know you are busy, but we still have to learn because the day we stop learning, that is when our brain will begin to deteriorate. Here we have a question. Where? The question is 4 to the power of a plus 9 to the power of b equal to 7. 8 to the power of 8 plus 27 to the power of b equal to 10. So we have two equations here and we are asked to find a and b. I saw this question somewhere and I asked myself, could this question be math Olympiad question? Yeah, it is a math Olympiad question. So if it is math Olympiad question, how do we solve for the value of a and b from this set of simultaneous equations? Now, in solving this challenge, it's going to take us some time, but I'm going to take time to explain everything bit by bit. Okay, so sit back as we cruise on with this challenge. Before we go to today's challenge, if you're new here, this is Online Maths TV where we learn mathematics all the time. So do it to subscribe, and when you subscribe, hit that notification bell so that you get notified whenever we drop an amazing video like the one you're about to watch right now. Now let's dive into today's challenge. We take our solution first thing first. The question is 4 to the power of a plus 9 to the power of b equal to 7, equation 1, and 8 to the power of a, okay, plus 27 to the power of b. This is. Now, the first thing we're going to look at is that this can be expressed as 2 to the power of 2, and this 3 to the power of 2, here 2 to the power of 3, and here 3 to the power of 3. So let's go ahead and rearrange this or rewrite this. So will now give us here 2 to the power of 2 in bracket or to the power of a, that plugs your 3 to the power of 2 also in bracket to the power of b equal to 7. And here we have your 2 to the power of 3 all raised to the power of a plus your 3 to the power of 3 or to the power of your b. Okay, this is equal to 10. Now, if you look at this, we are having 2 as an exponent, a as an exponent, 2 as an exponent, b as an exponent. So we can rewrite the exponent. Remember the law which says that if you have a to the power of m, then n, this is equal to your a to the power of m bracket your n equal to your a to the power of n or to the power of m. So if we interchange this, then we can rewrite both equation 1 and equation 2. So rewriting this will give us here your 2 to the power of your a or in bracket to the power of 2. Then plugs here will give us here your 3 to the power of b or in bracket to the power of 3. Okay, sorry, 2 to the power of 2 here. Yeah, power of 2. They're equal to 7. This will also be written as your 2 to the power of a, okay, or to the power of 3. There plugs your 3 to the power of b or to the power of your 3. Okay, so this is equal to 10. So let's continue on this side. Okay, now if we look at this carefully, we're having 2 to the power of a, 2 to the power of a, 3 to the power of b, 3 to the power of b. So we can bring in another alphabet. So if we substitute a different alphabet into this, let's use x and y. So if we say let x be equal to 2 to the power of a, 2 to the power of a, and y be equal to your 3 to the power of b. And so we can rewrite the expression here, which is this equation and this equation. So if we do that, we're going to have this now implies your x to the power of 2 there plus here we have y to the power of 2 equal to your 7. So we have this to be 7. Okay, let's erase this. Then the next one we have x to the power of 3, which is for this. There, plus y to the power of 3. This is equal to 10. Okay, let's erase this. Now, if we look at this, we now have a different equation now. So we have this is quadratic, this is trinomial. So how do we now solve these two equations simultaneously? We are going to make use of some special algebraic identity. Now, remember that if we have your x plus y all squared, we can use binomial expansion, okay, Pascal triangle to expand this. So if we use Pascal triangle to expand it, this will give us here your x squared, okay, plus your 2, this is 2 please, plus your 2xy, okay, then plus your y squared. Easy. So I can bring this and this together. So this will now give us your x squared plus y squared plus 2xy. Mind you, we have this down here, which is your x plus y all squared. If I decide to move this to this side of the equation, this will now become your x plus y all squared minus 2xy equal to your x squared plus y squared. This is what is left here. Now, if you look at this other side of the expression, x to the power of 2 plus y to the power of 2 is equals to 7. So we are having this expression. So we can equally replace this with 7. So this will now give us here, this now implies that your x plus y squared, sorry, all squared minus 2xy is equal to 7. So we formed another expression from here now. Okay, so we can equally look at this and use special algebraic identity to bring something like this. So if we have here your x plus y all to the power of 3, this is equal to, so if we use Pascal triangle or the binomial expansion to open up this, we are going to come up with your x to the power of 3 plus your 3x squared y plus your 3xy squared plus y to the power of 3. Remember this? Look at your Pascal triangle. 1, 1, then 1, 2, 1, 1, 3, 3, 1. For your third power, look at the coefficient 3, 3. Therefore, the first one we did, look at it here, 1, 2, 1, which is 1, 2, 1. Okay? All right. So with this, we can now rewrite this, bring this and this together. So this will now give us here your x plus y to the all to the power of 3 there minus, sorry, equal to your x to the power of 3. Bring this to give you plus your y to the power of 3 there plus 3xy is common to this and this. So this now give us here 3xy bracket. If we use this to divide this, we are going to left with x there plus, if we use this to divide this, we are going to left with y. Easy. Okay, now from here, again, let's continue on this side. Okay, again, I want to move this expression down to this other side. So we're not going to have this to be x here plus your y all to the power of 3 minus everything here. So we have 3xy bracket x plus y close bracket equal to, what is left here now is your x to the power of 3 plus y to the power of 3. Again, look at what we have here. X to the power of 3 plus y to the power of 3 equal to 10. So we can replace this with 10. So we have here x plus y all to the power of 3 minus 3xy bracket your x plus y This is equal to 10. Good. So we want to solve this equation and this equation. But looking at this very equation here now, in fact, let's give this equation 1 so that we don't get confused. This is equation 2. If we look at these two equations, we are seeing or having some similarity there. We are having x plus y here. We are having xy, x plus y. And also in equation 1, we are having x plus y, then xy. So we can do another crazy substitution here now. All right. So from here, we can now say, let your x plus y be equal to, this time, let's take p, and your xy be equal to xy be q. So let's rewrite equation 1 and equation 2. So if we say so, then our equation 1 will now becomes, this now implies your p squared minus 2sy q. Everything here is equal to 7. Let's give this equation 3. All right. Then we can now rewrite this. If we rewrite this, this will now give us your p to the power of 3 there minus your 3q, okay, into p close bracket equal to 10. Let's give this equation 4. Okay. All right. So we want to solve equation 3 and 4 again now for our p and q. So from equation 3, let's make q the subject of the formula. So from equation 3, say from equation 3, we want to make q the subject of the formula here. So this will now give us here your p squared minus 7 equals to 2q. Divide by 2, divide by 2. Cancel. So we have q is equals to p squared minus 7 all over 2. Let's give this equation star. You see that? Now from equation star, put equation star into equation 4. Okay, so wherever we see q, let's put it into this equation here. Okay, so if we do that, so this will now implies that our p to the power of 3 minus 3 into, what is our q? We have p squared minus 7 close bracket all over 2 into our p. This is equal to 10. Okay, so all we just need to do is to use these two to multiply everything, then open up this bracket here. So let's continue on this other side again. And this now implies your 2p to the power of 3, okay, then minus your 3 p to the power of q, okay, because here we have here p squared with times your p here to give us your pq, then plus, because minus here times minus will give us plus. So plus your 21, all right, 21 p, then equal to your 20. Any confusion? Now, all right, so 2pq minus 3pq, this will give us minus p to the power of 3, there plus your 21p, this is equal to 20. Rearranging, this will now give us, or we multiply by minus, then bring this to this side to give us here p to the power of 3, then minus 21p, then plus, because this will now turn to plus 20p, sorry, 20 is equals to 0. How? Because if we multiply through by minus, here we're going to have minus 20, and once it crosses the sign of equality, it turns to plus. Any confusion so far? No. So again, this is a trinomial equation. So how do we solve this? We're going to use the trial by error method to get the first factor to this. Now, if we put in positive 1 here, they will give us 21, then plus 1 minus 21 will give us minus 20. Minus 20 plus 20 will give us 0. So plus 20, sorry, plus 1 is one of the factor. So from here, we're going to have this to be P equal to 1 is one of the factor. So therefore, our P minus 1 equal to 0 is the first factor. So how do we now get the other two factors? I'm going to use the long division method to get the other factors from here. So let's continue on this side again. So here we have our long division method. So we have P minus 1, okay, into our P to the power of 3, then minus, now we don't have P to the power of 2, but I want to introduce P to the power of 2 to get a uniform division. All right, so we have here plus, but it's going to carry 0. So 0P squared, so 0P squared, okay, then minus 21P, sorry, 21P, then the last figure plus 20, plus 20. All right. So P into P to the power of 3 will give us P squared. Use this to multiply this. We have P to the power of 3. Then minus this time this will give us your P squared. We subtract. Then this will leave. So here we have your minus sign. This time this will give us plus. Plus 0P plus P squared will give us your P squared. Bring down this to give us 21P. Again, we use this P to divide this. So P into this will give us plus your P. Use this to times this to give us P squared. Then this times this will give us minus your P. Okay? We carry out our subtraction again. This will leave. This times this will give us plus. So 21P plus P will give us negative 20P. We bring the last term here, which is plus 20. Okay, we use this to divide this again, so we are left with minus your 20. So we use this to times this will give us minus 20P, this 20 please. Then this time this will give us plus 20P. If we rule off and we subtract again, this will leave, this will leave, so we have 0, 0. So our terms here, so the factors here we now have here, we have this quadratic equation. So we can solve this quadratically. So we have P squared plus your P minus 20 is equal to 0. So how do we solve this quadratically? It is easy. We can use the factorization method. Think of two factors of 20 that when you multiply together to give you 20, their addition will give you plus 1, and that will give you 4 and 5. So we're going to have minus 4 and, minus 5 and plus 4. So we can rewrite this as P squared minus 5P there plus plus 5 there minus here please minus 4P then minus 20 equal to 0. So again we can put this in bracket, put this in bracket, put this in bracket, put this in bracket. What is common is just P. So P here will give us P, then plus here will remain 5 close bracket minus what is common here is just 4. The 4 here will give us P. The minus times minus will give us plus, and 4 into 20 will give us 5 equal to 0. The terms in the bracket are the same. So we take one. So here will now give us P there plus your 5 bracket 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 your P minus 4 there equal to 0. Okay, so we've gotten the other two factors now. We can bring the first factor for us to get our 3 factors. So let's erase this side again. All right, before that, let's bring out all the 3 factors down here. So we have here the first factor P minus 1, the second one P minus 4. Okay, let's take that of minus 4 first. Then the next one P plus 5. Okay, everything equal to 0. So from here, we can have, or we now have, therefore, or this now implies that our P1 is equal to positive 1, P2 is equal to positive 4, and P3 is equal to negative 5. Easy. Okay. Now that we've gotten our P, we have to get our Q. Remember from where we made that substitution, we said Q, where we make Q the subject of the formula, so Q is equal to P squared minus 7 all over 2. Remember this? Okay, so let's get our Q1. So we have our Q1 is equal to, we have here 1 squared minus 7 all over 2, which is equal to 1 minus 7 all over 2, which is equal to minus 6 all over 2, which is equal to minus 3. You get that? Then we have our Q2 is equal to, what is the value of P here? We have 4. So we have 4 squared minus 7 all over 2. This is equal to 4 squared will give us 16 minus 7 all over 2. Then is equal to 9 all over 2. So we've gotten our Q2. Then let's go ahead and solve our Q3. Q3, we have minus 5. So we have minus 5 all squared. This is 5, please. Minus 7 all over 2. This is equal to minus 5 squared will give us 25 minus 7 all over 2. And so 25 minus this will give us 18 all over, it's 18 please, all over 2, which is equal to 9. Okay, so now we've got our Q1, Q2, Q3. Therefore, can I say therefore, our P1, okay, comma Q1 is equal to, let's put this in bracket, we have 1, comma, there Q1 minus 3. There our P2, comma Q2, this is equal to P2, we have here 4, comma Q2, we have 9 all over 2. Close bracket. Then our P3, comma Q3, this is equal to, our P3 is minus 5, comma, there you have 9. Okay, so here we have our PQ down to the 311. Remember the substitution we made the other side where we said let P be equal to your X plus Y and Q be equal to XY, right? So let's go and make our substitution into that. If you check this, because of this and this negative here, there will be no solution for A and B. And so these two are rejected. Okay, so we are going to reject this. This one is rejected. This one is also rejected. Okay, this is also rejected. So this is the only one we are going to work with. So we are going to go back to where we did that substitution. So let's continue on this side again. Although I said this is a bit tough, but we are going to get the answer straightforward. All right, let's go. Now say recall. Let's recall. We said P be equal to X plus Y and Q equal to your X, Y. So like I said, we are taking this. So if we are taking this, this will be equal to what? Your 4. And this will be equal to 9 all over 2. Okay, so for you not to be confused, let me rewrite this out. So we are having here X plus Y is equal to 4. Let's give this equation star, star. Okay, then Y here we have your X, Y equal to 9 all over 2. Let's give this as equation star, 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 star. Okay, so from equation star, 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 let's make X the subject of the formula. So if we do that, we're going to have this to be X is equal to your 9, okay, 9 all over 2Y. So from here, put this equation into equation star star star. So if we substitute there, we're going to have something like this. Again, let's continue here. So we're going to have this to be your 9, and this now implies 9 all over 2y, there plus your y is equal to 4. Let off this denominator. So we now have 9 plus 2y squared equal to 8y. If we rearrange, we're going to have 2y squared minus 8y plus 9 equal to 0. Now, this is a quadratic equation. So we cannot solve this quadratically. So solving this quadratically, we are going to use the quadratic formula. And so this now give us y is equals to your minus b plus minus the square root of your b squared minus 4ac all over 2a. What is our b? Minus 8. So we have minus bracket minus 8 plus minus the square root of minus 8 all squared there minus 4 times a is what? 2. 2 times, what is our c? 9. So we have here 9. So, okay? Everything here all over 2 times 2. So this will now give us 8 plus the square root of minus 8 will give us 64 minus 4 times 2 will give us 8. 8 times 9 will give us 72. So we have 72 all over 4. So if we simplify that, we have 8 plus minus the square root of 64 minus 72 will give us minus 8. So we have minus 8. Okay, all over, this is 8, please, all over 4. Remember your iota, right? Iota is equal to the square of minus 1. So we can bring that here to give us here your 8 plus minus the square root of 8 iota all over 4. Here we can write 8 as 4 times 2. So we can bring out 4 from here, and the square root of 4 is 2. Then this will now become your 8 plus your 2 into the square root of 2 iota all over 4. If we factor out 2 from here, 2 will cancel out here, we'll be left with 4. 2 will cancel out here. So let's continue on this other side. Again. All right. So if we factor out 2 here, this will now give us here your 4 plus minus the square root of 2 iota all over 2. So this is the value of our y. So we're having 2 values from here now. So we have our y1, comma y2 is equal to 1 all over 2 bracket 4, the plus minus the square root of 2 iota. Okay, we've gotten our y1 and y2 now. So let's go ahead and get our x1 and x2. Now look at here. We've made x the subject of the formula already. So from here, we can now get this from here. So we have 9 all over 2y. So we have x is equals to 9 all over 2 into 1 all over 2. So let's use the square bracket here. Then into your 4 plus minus the square root of 2 iota, close bracket. Okay, let me take the 9 to the middle. So we have here 9 here. This 2 goes with this 2. Okay? All right, so since we have this, we now have x is equals to 9 all over your 4 plus minus the square root of 2 iota. So now we are having x1 and x2 in here again. Now we've gotten this now. Then we now go back to get our a and b. Recall, we made another substitution again where we said let x be equal to 2 to the power of a and y be equal to 3 to the power of b. So from here we now say recall where we said that your x be equal to 2 to the power of a and y equal to 3 to the power of b. Now that we got our y and x, so let's substitute. This is the last lap. This now implies, what is our x? So we are going straight to x1 and x2. So we have 2a here, so let's go 2 to the power of a equal to your 9 all over your 4 plus minus the square root of 2 iota. All we need to do is to ln both sides of this equation. So we have here ln of 2a is equals to the ln of bracket your 9 all over 4 plus minus square root of 2 iota. Okay? Then what happened? Move this backwards. So we have your a ln of 2 equals to the ln of bracket 9 all over 4 plus minus the square root of 2 iota. Okay, so we divide through by ln of 2, divide through by ln of 2. This leaves. So we now have our a is equal to the ln. Now we can apply the division law here. Okay, so if we apply the division law of logarithm, we're going to have here 9 minus the ln of bracket 4 plus minus the square root of 2 iota close bracket all over the ln of 2. This is the value of a. Okay, now let's go ahead and look for the value of b. From here we said y equal to 3 to the power of b. And what is our y? Again, look at our y. So we have the two values from here. So we're going to have here to be 3 to the power of b equal to the 1 all over 2 into the 4 plus minus the square root of 2 iota. Okay, again we ln both sides of the equation. So this will now give us ln of 3 to the power of b equal to ln of 1 all over 2 into, let's put this in brackets, square bracket rather, 4 plus minus the square root of 2 iota. Okay, move this exponent backward. So let's continue on this side. So all the way from the other side, we're going to have this to be your b, okay, ln of 3. This is equal to your ln of your 1 all over 2, okay, into our square bracket, 4, the plus minus the square root of 2 iota. Sorry, I'm trying to conserve the space here. Okay, so you have here this. Okay, so from here, what happened? We divide by ln of 3. We divide by ln of 3. This leaves. So we now have b is equal to the ln of your square bracket 1 all over 2 or into your 4, then plus minus the square root of 2 iota close bracket into our square bracket all over ln of 3. So this is our b. So we have this is the value for b and this is the value for our a. Although tough, but at least we got to the roots, to the final answer. All right, so this is all I have for you for today. If you like what has just happened here now, give the video a thumbs up. And if you observe any error, do not hesitate to drop it in the comment section. And also, if you have a better way of solving this challenge, this math Olympiad challenge with less stress, there, leave it in the comment section so that we can equally learn from you. Again, this is Olympiad TV and my name remains Jakes Anemo. As we prepare for the Unitide, do not forget to celebrate with your loved ones, your friends, your neighbors, and at the same time, never forget to learn, because learning helps to sharpen your brain. It opens your horizon. Okay. Thank you. Remember, this is Jakes Anemo. And you know what? I love you always. Bye for now.